Data is one of the most valuable things that an organization has, and we need an efficient way to deal with data. So we can use SQL or SQL, structured query language, to deal with all of that data. Since it's so valuable for every organization, it's really valuable for your career if you know SQL well. So in this video, I'll explain the most important concepts that you need to know about SQL. And we're going to look at through the perspective of a bookstore. So you can imagine a bookstore has data on, for example, each book they have, the price of each book, the author of each book, how many sales a book got every month or so. Now, if you're the owner of a bookstore, you could keep track of all of the data with pen and paper, and that is what people used to do. It's very hard that way, if you have a lot of data, to perform useful analysis on that data. So as an example, you want to know which books generate the most revenue. If some books are making you a lot of money, you want to feature them more prominently in the store or online on your website, for example. Also, you need to know which books are not selling well, because maybe you don't want to purchase them anymore. You want to remove them from your inventory. If some books are getting a lot of low ratings, you maybe also want to remove them, or at least not to display them prominently anymore. Now, maybe you notice that some books or some genres are selling really well during some holiday period. So the next time you know that you can perhaps promote those books online, right? So all sorts of marketing insights you can get. So that data analysis can really make or break an organization. And that's why it's so valuable to know SQL, because SQL helps you do all of that analysis. So I want to store my data in a database. Now, there are various databases that you can pick from, database management systems, official term. Now, I'm using MySQL here because I'm using this website to showcase all of this, but there is also Postgres, there is SQL Server from Microsoft, there is SQLite, but it doesn't really matter for learning SQL which one you pick. Now, when you pick one of those systems, you often actually have to create a database first. So you actually have to run some command to create the database. This may have already been done for you, and then you can use the database. So now we have a database. Do we just start dumping a bunch of data in there? And actually, no. We want to be strict with the structure, right? Structured query language, so that the database system can optimize it efficiently, but also so that when we get the data out, we know the exact shape and structure it has. So typically, the first thing you want to do is actually create tables to define what the data should look like. So a table, you can imagine a spreadsheet with columns and rows. So we're defining here what the columns should be. Now, in a bookstore, we have a bunch of books, and each book may have an ID and some title. Now, each book also has an author, so we could technically add all the author data just to each book as well. This is called denormalized, but in practice, people want to normalize the data. So basically, important entities have their own table. Now, by the way, about the name of these tables, you could also in the plural way. You'll see this sometimes. Now, typically I like to stick to singular names because every word has a singular version. For example, the word news. What if you were doing the plural way? How would you pluralize words like this? You prevent a bunch of issues by making it all singular in my view, but some people do prefer to make it plural. Right, but both work. So let's say we have books and authors also have an ID and a name. And the benefit of normalizing the structure, so basically separating it out in different tables, is that you don't have unnecessary duplication, right? Because different books may have the same author. We may want to keep track of the published year, the price, the rating, and also when we created information in the database. So now we have defined essentially what the data should look like, and we now start dumping a bunch of data in here in our database. And actually, no, we can be even more specific. So we can also specify the data type of each column here in the table. So we want these IDs to be so-called integers, right? So 1, 2, 3, and the name of the author should, for example, be some string that can have up to, let's say, 100 characters. And the same for the title of each book. This one can be an integer again. Now, price probably should not be an integer, right? Because typically these can have decimals like $9.99. So we can specify the total length of the number and then also how many decimals there can be. So rating, we can make this an integer. And when did we insert the information? This is typically a timestamp or perhaps some kind of date. We'll talk about that in a second. Now, before we continue, I quickly want to mention today's sponsor, which is DataCamp as well. They have a wonderful SQL track that you can follow if you really want to master SQL, which I do recommend if you work with SQL in your work, for example. So you will learn all about what we're discussing in this video and way more. So of course you start off with an intro, but it's not just for beginners. So you go to an intermediate level after that. And what I really like about it is that it's not just watching videos or reading. They actually have a really nice set of projects as well. And actually the exercises they give you are quite realistic. So this is how you could come across them in the real world as well. And you will learn about joining data, manipulating the data, and more advanced concepts as well, like how to do database design, right? How to structure things, how to organize the data efficiently. So I would say check it out. You can find a link in the description. Now, DataCamp also offers a SQL Associate certification. So if you really practice SQL, you can go for the certification here, and this can help you prove that you actually know SQL properly. So I would say check out both links in the description. So now it's even more specific. Can we now start dumping our data in our database? And not yet. There's one final thing that we also typically want to do here is specify some constraints. So I'm going to make these IDs a so-called primary key, meaning if we want to be able to uniquely identify some author or some book in our database, we need to use the ID. This will also ensure that the IDs will stay unique. For these IDs, I can actually also add auto increment so that as we insert data, the database system will automatically increment the ID 1, 2, 3. We don't have to come up with an ID ourselves. When we insert data, can we leave off the name of the author, for example? This should always be specified. This is very common that you say not null. So when you insert data into the author table, it has to have a name. We want to do the same for the title of each book. We could do the same for published year, but maybe we don't know the published year of some really old books. So we can say if we don't know, the default is maybe the number 1900. For price, we definitely want to have a price and a rating as well. Now, what if you know that the rating always has to be between 1 and 10, let's say? So when we insert data, we don't want to have a mistake where somebody inputs 1000. So we can have a constraint here. We can check actually to make it a little bit more specific. So it has to be between 0 and 10. So you can have check, and then you can have some logic here using between and to make sure that the number stays between 0 and 10. For this created at, this is useful for knowing when added the information to the database. So it's nice to keep track of that. We can say that when we insert it by default, it should just take the timestamp of that moment. So can we now finally add the data to the database? Almost. One final thing I want to do here, which is we have now created two isolated tables here. They are not connected in any way. You may hear about relational data. So typically if there is a relationship, we also want to describe what that relationship here should be. So of course each book will have some author, and an author will have some books. Now typically that you can do it is, for example, to keep track of the author ID here. So each book will have an author ID, which will be an integer and must be specified. And that's just going to be whatever the ID is for an author. Now we do need to be specific about that relationship. So we have to say there is a so-called foreign key here. So basically this author ID that we just specified, this references the ID, this one, in the author table. So if there is an author with ID 5 and some book was written by that author, we want to have an author ID of 5. Now if we assume that one book can only have one author and one author can only have one book, in that case, it would be a one-to-one relationship. Now, in this case, we're going to assume that each book has one author, but one author can have multiple books, right? In that case, you have a one-to-many relationship or a many-to-one relationship, depending on whose perspective you're looking at it. There's also something called many-to-many relationships. So maybe we have categories, for example. A category can have multiple books, and a book can be in multiple categories, right? So then you would have a separate table typically for that type of relationship. All right, now finally we've done the hard work. We have specified what we want the shape of the data to be. Now it's time to actually insert some data into our database. So I have my actual queries into the database. We'll talk about what all the queries are. So let me actually expand this a bit here. So when you perform queries in your database, the most common one is actually getting data out. That would be select. We'll talk about it in a second. But initially there is no data yet. So we actually have to insert the data, right? So creating data, you do it with insert. There's also update if you want to fix a mistake, for example, or you want to delete something, you use delete, right? But first we need to actually have some data in a database. So we say insert into which, well, for the author, what do we need to specify? Well, only the name. The ID is done automatically for us because we specified auto increment, but we say not null here for name. So we should for sure specify what the name should be. And then here we have all the value, right? So here we have 5 authors. All right, so then what are we inserting here into the book table? Well, we know that we have to specify not the ID because it's automatically done for us when you insert this data, but we have specified not null basically for the other one. So we should specify title, published year, price. You can see these have decimals, at most 2. We have rating should be between 0 and 10. You can see they are indeed between 0 and 10. And here we specify who the author is of this book. So this book is referencing an author with an ID of 1. So when it creates this data, it will actually assign this number to this author. That's how we know That's how we connect this type of data. When you insert a bunch of data to start playing around with the data, this is also called seeding the database. That's what we're doing here. We're seeding the database so we can start working with the data. You're just working with dummy data. That's actually what we're doing here. We're just learning things. If you're creating an app, for example, play around with the real data, you may have a set of dummy data so that you can at least test how everything works. So sometimes you have to delete things, etc. So you would seed the database so that you can start working with it and just testing things. All right, so that's enough talking. Let's actually try running this. So I'm going to run everything that we have here. I'm going to click on Run SQL. All right, so I just ran the query and actually ran into an issue here because I was using something with check here. And so this is a good example of why the database that you're using, which version you're using, may not allow for certain things. So actually check does not work here with my setup here. So I actually just removed it. We'll just have it as an integer. And then this website actually gave me a nice overview here. So you can see we have two tables in our database now, author and book. They are structured like here. And there is a relationship here between the author ID in the book table and the ID here in the author table. You can see there's a key symbol here because these IDs are the primary key. This is how we can identify each individual item. Now actually on this website I need to put the insert as well on the left side here. So I just put it below the table creation here. That's just for this website. So we now have inserted our data, but we don't see anything yet. How can we now actually see the data or basically get the data out? To get data we use select. I want to select everything from my database, but you do need to specify from which table, right? So here I want to get everything from the book table. So if I run this, you can see I get my data right here. Let me pull it up a little bit. You can see I can select all the data from my book table. And so it will give me each record here, right? Each row is one item in the database, right? So we have columns and rows, right? Very much like a spreadsheet. So these columns are title, for example. This is also called a field. And we can see we have one book here that has an ID, has a title, year, price, etc. Right? Automatically added some data like the ID. We didn't have to specify that. Also the timestamp for when we inserted it into the database, and it's also pointing to an ID of the author of that book. So if we want to see all the authors, so if I want to see author ID 1, which author is that? Well, I can get all the data from the author table. Now you can see, okay, so it was the record with an ID of 1 in the author table, which has a name of this. Let's go back to the book table. Typically, this is not so common, right? So typically you don't want to get all the data from your database. Imagine you have thousands or millions of pieces of data, and for many types of analysis, you don't need all the data. For example, maybe I'm trying to calculate the revenue. So maybe I only need the price of each item. I get this. Now maybe also an ID. So I can have multiple columns here, ID and a price. Right, so now an ID. So now I get the ID of each book as well as their price. And let's say I also want the title. In that case, I would get ID, price, and title. Right. So typically you want to be a little bit more specific with what you actually get. So here in the results, it's called price. I can also rename this. So maybe this is without discount, for example, like full price, you could say. So in that case, I get the same result, but the name of the column will now be a little bit more specific. Now, when you run a query like this, we are only limiting the number of columns, not the number of rows. So we are still getting all of the records, all of the items from our database, all of the books from our database. It doesn't matter if you do it like this or this. This is just the columns, right? But you're still getting all of the books. So if you want to limit the number of rows that you get, we have the where clause. So we can say only the books where the price is, let's say, greater than 12. So now you can see it has limited the books that I get, but I have all the columns, right? So I selected all the columns, but the number of rows, but the rows are specified like this. And it can be other things as well, like the published year can be between two numbers, right? So we can say between, and then we have and. So you can do all sorts of filtering essentially on the data that you get back. So here we can see we only have the books with published year between those two numbers. So that's basically filtering. We can do also a bunch of filtering with text. So we can say where the title is something like the in front of it, and then there can be anything coming after it. So now we get all the titles that start with the and then a bunch of stuff after. If you do the percentage sign in both sides, you will get the books that have journey somewhere in the title. right? Whether it's at the beginning, right? Could be in the middle of the name as well. Could be other things both at the end as well in the front. We can also say all the books where the title is in some list of possible options you may have, or the opposite, that cannot be those two. So everything else but these ones in this list, right? You can make all sorts of combinations. We can also work with and or conditions. So here we have a condition where the author ID should be some value or the published year should be some value. Either one of them, if one of them is true, the book will be retrieved from the database. You can make all sorts of wild combinations. So you can say where the published year is greater than 2010 and some other condition also has to be true. But that condition itself, for example, the price should either be less than 50 or the rating should be greater than 8, right? So here we already get into more complex logic. Now, sometimes you will see an extra set of parentheses here. This is just to make sure this is one condition in this AND block here, but it itself is using this OR operator. You can combine these things, and so we would get a result. Now, you can also just use equal, right? So equal where some price column is equal to a specific value, or where it's not equal. So I want to get all the books that do not have this title. Let's say you want to get all the books that were inserted into the database in the previous week. So here we can say select all the books where created at is greater than or equal to some date. Now this looks a little bit tricky. What we want to do, we may want to run this query, let's say in 5 months from now as well. We don't want to hard code, right? So we don't want to hard code, let's say, some specific date, because if we then run the same query 5 months from now, it's not going to work, right? So here you need something that can look back 7 days in a more dynamic manner. So we take whatever now is the value, and then we take that 7-day interval. Right? Working with dates is actually quite tricky. So some people will actually try to insert data not in a date, not as a data type, but as a string or as a string or like text, and then manually convert it to a particular date again. We can also sort the data. So I want to get all the books, but I want it ordered by the price. So we have ascending, meaning it starts off low and it ascends higher, right? So you can see the price here becomes higher and higher. The alternative is descending. So it starts off high and it goes lower and lower, right? Descending. I can also limit the number of results I get. So I can append limit and then some number. So I will have only 5 records from the database now. We can also get more aggregated data. So let's say I just want to know how many books there are. So I can select everything or the count of that from the book table and I will get 10. Now it's not really nice to have this weird column name as in the result. So I can also give it a different name here. I can rename it with an alias so that it looks a little bit better, so that it's clearer what this number means. I can also take a sum, so I can take all the price data and sum it together, and maybe you're doing some kind of revenue calculation, so we would do total revenue. What if I want to know the average price in my table? I can use average here of each price, and now I know the average price of all my books. If else type of logic here in SQL. So let's say we want to see the title and the price of each book, but we also want to group them together essentially in a particular category. So here we can say for the third column, right, we say that's going to be called price category. Now we will have some conditional logic. So if the price is less than 10, then the value for that row should be budget actually, and otherwise mid-range or premium. For the column we have some if-else condition, right? So here for that, right? So this is case for if-else logic. All right, so we have 2 tables in our database, one for authors and one for books. We often want to combine information, right? So if we get all of the books from our database, it will give me the ID of the author of that book, but I maybe also want to see the name of the author. Right, so I want to combine data from the other table as well. Now I could technically do it in 2 round trips to the database. Right? The first round trip, I would just get the book data, right? So now I would know, for example, this book has an author ID of 1. Then I would select, right? And then the second time I make a query to my database, I could select from my author table the one where the ID is actually 1, right? So then you have 2 queries to get the author data as well. This is considered not efficient. It would be more efficient if we can do it in one go. So we can use joins for that. So it looks a bit complicated, but it just makes sense because we want to combine data from multiple tables and we want to do it in one go. So let's say we want to have from the book table, I want to see the title of each book and I want to see the name of the author next to it. Right, so that's what we select here for the columns. So we have title as well as name. Notice I'm using the name of the table here because we're using a join. So we need to specify the title in which table, right? Because we're working with multiple tables now from book, but I'm joining that, it's called inner join, with the author table based on the author ID of that book being equal to the ID in the author table. So this book has an author ID. Find the one that is equal to that ID in the author table, and you will get the name here. And we're taking the name of that one. Right? It looks a little bit complicated. So if you're confused, I think that's totally normal. So with inner join, we're only going to get results here if they match, if there is a match in both tables. There's also left join. So then if there was, for example, a book, but it couldn't find the proper author, it would show null for the author, right? And vice versa for right join. And some databases also have full outer or cross join, which do more complicated things. But fundamentally, the idea is that you have some combination from different tables. All right, so we can select the title of each book. Right, so we get all of the books with their titles. Now, maybe we noticed that somebody, when they input the data, they were a little bit sloppy, and they also added some space before or after the title. So we can use some functions here in SQL as well. So we can take that title and trim it. It will remove the white space. And let's actually rename it to trimmed title in that case. So in our case, it would look the same. Trim would do it for both sides, but maybe you only want to remove it from the left side. So you say left trim or right trim, RTRIM. What if we only want to get the first characters of each title, let's say? So you take the title and we say character 1 to 4 are the only characters we want. So you can use the SUBSTRING function and it will give you the following. We can actually rename that, right? By default, the column name is a bit strange, so we use a lot of aliases. We can say prefix perhaps. We also have the length function. If we want to know the length of each title, basically how many characters, we can rename that to title length. We can use these functions in where clauses as well. So it's not just here for the columns and the actual data. It's also for filtering the data that we get back. So far, we've mostly looked at select. This is for getting data. And this is the most common query you will make. Now, we've also seen insert, right? Creating data in the first place when we seeded the database with the initial data. But we also have update. So let's say we already have some data, but we made a mistake. The price wasn't correct. So we want to update in the book table the prices, right? So here we can say the price should actually be 5% bigger, right? So the price should each be point multiplied by some number. And we can even have the same filters, right? So only for the books that have some particular published year. And we can also delete. So we can use delete from a particular table, and then we can have a filter. Right, makes sense for deleting. You need to specify what you want to delete, and it can be some ID, right? So you will hear the term CRUD sometimes. So create is what we do with insert, right? So we have creating data. We do that in SQL with insert. We have reading data. You do that with select. You have updating data. We have update and delete data. You can also drop an entire table. So if I would run this code, it would remove all of the data from that particular, it would remove the entire table, including all of its data. So you want to be careful with this. Sometimes you will hear about so-called transactions. This is typically relevant when multiple things have to go right for the entire operation to go right. So an example of this would be when somebody tries to buy a book from us. Basically, we should keep track of how many books we have in stock. And if somebody's going to our website and they're trying to buy, but the stock of that book is 0, we do not want to insert any data in our order table. Right? Imagine we have an orders table where we keep track of all the orders that customers place. Right? So basically, before we can update the order table, update for the stock should also go all right. So what you can do is you can say, we say begin transaction. So somebody's trying to buy a book. So we're going to update that book. Specifically, we're going to set its stock to -1. That's what we will attempt to do first. Now let's say that goes wrong because the stock was already 0. So in that case, we will raise an error here and we will not continue here. And now if everything goes all right, we can insert the information into our orders table, right? So there's a bit, right? So you don't have to understand everything that's going on here. The point being is we want to do 2 operations on our data essentially, but in order to do the second one, we want to make sure that the first one has gone all right. And if that doesn't go all right, we don't want to continue, right? So if we did not use a transaction here, something may go wrong with the stock, with the update here for the stock of the book, but we would still then insert the data into our orders table, right? We don't want that. These 2 updates that have to happen are sort of connected. They depend on each other to be successful. Otherwise, none of the updates make sense, right? So here we want to sort of group them together in a transaction. And only if they are both successful will we go to the end here and actually commit everything and update everything. There are some ways that we can optimize things as well. A very common one is using so-called indexes. So just to build some intuition on this, let's say we have all of our books data here, but we have some query that tries to find all the books with a price lower than 10. So what the database system would kind of have to do is, you can imagine it would have to go over each row, right? So we check the first one, is the price lower than 10? No. This one, no. And here, yes, this price is lower than 10. Can it now stop searching? No, right? Because now it has to keep searching, because there could be other books that have a price lower than 10 as well. So it will check this one and this one, and it will go through all of the records in our database to check this. An optimization here would be to create a so-called index on the price. Now, what that will do, you can imagine, is that it sort of creates another table with all of the books data, but it will sort the data. So now if there is an incoming query looking for all the books lower than 10, looking for all the books with a price lower than 10, well, since it's sorted, now it will go through each record again. So now it will start going through the record. So here, oh yeah, the price is lower than 10. So this is one book. There could still be other books with a price lower than 10. So it will check this one. Is this one lower than 10? And no, actually this price is higher than 10. And now it knows, hey, this is sorted. So there's not going to be any price lower than this. So we are already finished, right? So the fact that you can sort data helps the database a lot in optimizing this. This is just a quick example, but that's approximately the optimization that you make with an index. It's typically recommended things that you query a lot on. So if you query a lot by price, it makes sense to create an index on that price. It comes at a cost of slower writes. So we have reading data, basically select the data. There are also writes. Writes are updates. So we may want to update data, delete data. And if you have an index on there, since it needs to replicate the data in the other table that you created as well, that's how you can think of it, it's going to be a little bit slower. If you're a data analyst, you may work with these so-called business intelligence tools like these dashboards. These dashboards essentially run SQL queries under the hood for you, so you can visually interact with the data. So those dashboards will actually also run queries like this, when they will select all the prices from the books, right? They will get the price of each book. And maybe if we were keeping track of the quantity sold of each book as well, then they could also see how many were sold. And then the dashboard would perhaps multiply that together to get the actual revenue, right? And then they have some other code to turn that into a nice graph, for example, right? It's all SQL under the hood, and maybe some apps and maybe some web development code, maybe with Python or with JavaScript. What's also really common if you're a programmer building apps is migration. Typically, when we're playing around with our app, we're building our app and we're testing things out, we have a separate database than the real database in production, that our actual users with real data are using. So we have two databases, and this makes sense because we can make many mistakes as we're building the app, we're trying things out. So we don't want to work with the real data. So during development, as we're playing around, testing things out, we may actually want to update our database. So we decide, hey, actually, you know what, the book table should actually have a column for discounts as well. So now our other database also needs to be updated. So basically we need to give instructions to the other database on how to update, so it's in line with what we have in development as well. Also relevant if you have multiple people on your team and they're all using their own local database, well, all the databases need to be in sync, right? Their structure all needs to be the same. So there needs to be an instruction for the other databases on how to update themselves. So this is typically called a migration, and it's basically just SQL code. And we were writing our own SQL queries here. If you're a programmer or you're creating some kind of app or software, often you don't write the raw SQL queries yourself. You use a so-called ORM, Object Relational Mapper. For example, SqlAlchemy is a popular one. So this would be maybe some code, some Python code perhaps, or maybe using JavaScript. Instead of writing raw SQL queries yourself, you would use the code that the package gives you in order, for example, to create a new author and then update that in the database. That ORM under the hood would still produce those raw SQL queries. It's just abstracted away from you. The benefits of using an ORM like that is that you don't have to learn or be perfect in your raw SQL queries. So it reduces the odds that you make a mistake with the raw SQL. And it helps you with other things as well, like the types. If you're not a programmer, you're not creating apps, this is probably not something you will see. So that was a quick overview of SQL. Don't worry if you're a little bit confused, totally normal. There's a lot of things to learn. Hopefully this helps you out. Check out DataCamp. I want to thank them for sponsoring this video. And I want to thank you for watching. Have a nice day. Bye.